So today we are going to start magnetic effects of electric current. Ayukta, we will study all the things in this chapter, but still can you tell me what do you mean by magnetic effect? Magnetic effect.
Mom, I don't know.
Magnetic effect. You observed, you have heard magnets, whatever you know about it.
Ma'am, it has the ability to pull iron objects towards itself.
Very good. Magnets, which attracts magnetic object towards itself like iron. Tanya, what you know about the magnetic effects? Whatever you know, we will study all the things in this chapter, but whatever you know, you can tell me.
Mom, they attract metallic objects like iron
Hmm.
and
Bar magnet, you remember?
yes, mom.
In bar magnet, there are two poles, north pole, south pole.
Yes, mom.
Hmm. So, magnetic effect of electric current. We are going to start this chapter. By the name of the chapter, it is clear that the magnetic effects also produced by the electric current. Okay.
Yes, mom.
In chapter electricity, which type of effect we studied, which is produced by electricity?
Heating effect.
Heating effect means electricity produce heat, like electric kettle, geyser, egg boiler, sandwicher. In all that we use heating effect of electricity. In this chapter we will study magnetic effect of electricity. So in previous chapter we studied about the heating effect. Here we will study about the magnetic effect. Look at this diagram, this circuit. This is the resistor. This is the long straight conductor. Can you see? And here A, B, C, D. What is it? Here compass needle is suspended. Key. What is the use of key? What is the use of key?
Mom, this switch is a conducting link between the battery and the
Hmm.
bulb or in a circuit,
Huh.
usually.
Usually. This key is used to switch on or switch off the circuit. And this one
Yes,
is
ma'am.
the battery. Ayukta,
Yes, mom.
is the flow of current is same as the flow of electrons? Flow of current is same as the flow of electrons?
Mom, I don't know.
You know, flow of electrons is same as the flow of electric current?
No, mom.
No, it is opposite. If electrons are flowing like this, a current will flow like this. You know, in class I told. So what will happen when in this circuit current will flow? Current will flow, there is deflection in the compass needle. This deflection shows that the magnetic effect is produced because this compass needle always try to stop in north south direction. Are you getting?
Yes, ma'am.
Always trying to stop in north south direction. So deflection in this compass needle shows that there is magnetic effect of current. Yeah, or there is magnetic effect in the circuit. And how it is produced? It is produced by the electric current. Okay.
Yes, ma'am.
Okay.
Ma'am, deflection means
Deviation, movement from its position.
so it was already pointing in the north south direction, then it gets deflected.
No, it
Or
is always stays in north south direction. Okay. But if there is deflection, so it means magnetic effect also in its surrounding.
ma'am, why is it called magnetic effect if the compass starts deflecting? Because already it's a property of the magneto point in the north south direction, no, ma'am. Then why, if it's deflected, then why is it called the magnetic effect?
Because it shows deflection when it comes in the contact of the magnetic field. Are you getting my point? Magnetic compass needle. Okay, suppose you are like hanging it in different directions. uh, Compass needle like Tanya, suppose you are moving it, so its needle will also move. This is due to the magnetic effect of earth.
Oh,
Are you getting my point? Because earth shows also magnetic effect.
yes, ma'am.
And here it is moving, it means there is something which is producing magnetic effect. That's why it is getting deflected.
Acha. Okay. Yes, ma'am. Understood.
Okay. Aita, are you also okay with it?
Yes, ma'am.
Okay. So it means there is magnetic effect. And this is from where this magnetic effect is coming? It is coming from the electric current. Start to read from here. Tanya, if there any other confusion, it will be clear definitely, as we will study all the things in this chapter. I
Yes,
can
ma'am.
explain again. Yes, start from here in the previous chapter.
In the previous chapter on electricity, we learnt about the heating effects of electric current. What could be the other effects of electric current? We know that an electric current carrying wire behaves like a magnet. Let us perform the following activity to reinforce it.
Hmm.
Activity 13.1. Take a straight, thick copper wire and place it between the points X and Y in an electric circuit as shown in the figure.
Hmm.
The wire XY is kept perpendicular to the plane of paper. Horizontally place a small compass near to this copper wire. See the position of its needle. Pass the current through the circuit by inserting the key into the plug.
Hmm.
Observe the change in the position of the compass needle.
Compass needle. Aita, now you start.
We say that the needle is deflected. What does it mean? It means that the electric current through the copper wire has produced a magnetic effect. Thus, we can say that electricity and magnetism are linked to each other. Then, what about the reverse possibility of an electric effect of moving magnets? In this chapter, we'll study magnetic fields and such electromagnetic effects. We shall also study about electromagnets and electric motors, which involve the magnetic effect of electric current, and electric generators, which involve the electric effect of moving magnets.
We see that the needle is deflected in this circuit. Compass needle is deflected. What does it mean? It means that the electric current through the copper wire. Electric current is going through the copper wire. It means it is producing magnetic effect. Or what the other statement which we can give, that the electricity and magnetism are connected to each other. What is the reverse possibility? Suppose current is going like this, then what is the direction of magnetic effect? And if current is reversed, so magnetism will be reversed or not? So we will study all these things in this chapter. What are electromagnets? As clear by name, magnetism which is produced by electricity is known as electromagnets. And electric motors, electric generators, these also work on the electric effect of moving magnets. I have to check that, but according to me, these topics are removed from the chapter, from the syllabus. Electric generators or electric motors.
Yes, ma'am, they are.
They are removed. Yes, correct. And here we will study about the Hans Christian Ørsted, who has shown the magnetic effect due to electric current. Okay, start to read, Thanya.
Hans Christian Ørsted, one of the leading scientists of the 19th century, played a crucial role in understanding electromagnetism. In 1820, he accidentally discovered that a compass needle got deflected when an electric current passed through a metallic wire placed nearby. Through this observation, Ørsted showed that electricity and magnetism were related phenomena. His research later created technologies such as the radio, television, and fiber optics. The unit of magnetic field strength is named the Ørsted in his
His
honor.
honor. Okay, so Hence, Christian Ørsted shows the connection between magnetism and electricity. Now, magnetic field and field lines.
Ma'am, how did almost every scientist back then only accidentally discover something?
Because Tanya, you have heard many about many scientists that they are not studying properly in school. They are doing like mischiefs and they are thinking about that what is going like that. So this
Yes, ma'am.
happens. Why this happens? They are using many more percent of their brain. Okay,
Yes,
what
ma'am.
happened, Tanya? Sometimes we observe new things in our life, but we never further study about that. Sometimes we observed, yeah, why this happening, it is new thing for us, but till now many things are discovered. We can find every answer in Google.
Yes, ma'am.
But this your question is very interesting. Why they are getting all the things accidentally? Because they are doing something mischiefs, naughtiness like that.
Ma'am, I'm sure at least ma'am, almost all of the discoveries are labeled that way. I'm sure that at least a few of them,
Yes,
like they must have been wondering about it for years. They
yes,
always.
yes, yes. Huh, you
Mm.
are absolutely correct. This is not the work of any one scientist. But definitely what will happen, suppose they discovered more things like that, means they discovered, they defined it properly. But definitely it is the work of few scientists, team of few scientists.
Yes, ma'am.
Magnetic field and field lines. Magnetic field means, suppose this is magnet, till where it will show its magnetic effect, it is magnetic field, and it is shown by the field lines. Okay,
Yes, ma'am.
start to read. Aita, it's your turn, I think.
Yes, ma'am.
Hmm.
Magnetic field and field lines. We're familiar with the fact that a compass needle gets deflected when brought near a bar magnet. A compass needle is in fact a small bar magnet. The ends of the compass needle points approximately towards north and south directions. The end pointing towards north is called north seeking or north pole. The other end that points towards south is called south seeking or south pole. Through various activities, we have observed that like poles repel, while unlike poles of magnets attract each other.
So here what we are studying about the topic magnetic field and field lines. We are familiar that the compass needle gets deflected when brought near a Bar magnet. Can you tell me what is the meaning of the word bar magnet? Bar means, you can see here, it is like that, rectangular in shape. You remember in 8th standard, 7th standard, we studied about the bar graph. You remember
Yes,
or not?
ma'am.
Bar means
Ma'am, we still,
still
I think even in ninth we did bar graph.
bar graph. So bar means related to rectangular shape. So bar magnet, it is like that. So a compass needle, it also acts as a small bar magnet. So the ends of compass needle points approximately towards north south direction. Why always in north south direction? Why always north south direction? Due to the magnetism of earth. And north pole means north seeking, north direction, south pole south seeking, south pole. And same thing, like poles will repel each other, unlike poles will attract each other. What is the question? Hmm. Read the question.
Why does a compass needle gets deflected when brought near a bar magnet?
Hmm. A compass needle. Can you tell me, Ayukta, answer?
Ma'am, is it magnetic effect?
This is due to the magnetic effect. What about you, Thania?
Ma'am, due to the magnetic effect of electric current.
Electric current. A compass needle is a small bar magnet. When it is brought near a bar magnet, its magnetic field lines interact with that of bar magnet. Hence, a compass needle shows a deflection when brought near the bar magnet. Are you okay with it? We'll
Yes,
continue
ma'am.
from activity 13.2 tomorrow. Now we will do some questions of electricity which are still remaining. So according to my paper, we have done till 7th question. Now you remind me that we have done 7th or not? I explained 7th according to me. Yes, students, please confirm.
Ma'am, you were going to show us how to plot the graph.
Okay, read the 7th question. I am reading. The values of current I flowing in a given resistor of a corresponding values of potential difference like 0.5 ampere current, 1.6 volt potential difference 1, then 3.42, then 6.73, 10.24 and 13.2. So here you have to plot a graph between V and I and you have to calculate the resistance. So you can easily plot the graph or not? Do you need help in that one also, in plotting the graph? Please confirm, students. According to that, I can explain.
Ma'am, can I help in plotting the graph?
Sure. So what we will do here, values are given. Here values are given. Before continuing the plotting of graph, I want to confirm from you, uh, on x-axis which physical unit should I take? Potential difference or current?
Potential difference.
Okay. Tanya, did you get this thing? On x-axis we will take potential difference. No. Tanya, are you there?
Yes, ma'am.
Can you tell me that is it correct? We will take potential difference on x-axis. Okay, you know about this thing that we take actually x-axis, y-axis while plotting the graph.
Yes, ma'am.
X-axis horizontal, y-axis vertical.
Yes, ma'am.
On x-axis we take the physical quantity which is independent. Potential difference is independent and current is directly proportional to potential difference.
Difference.
Are you getting?
Yes, ma'am.
So here on x-axis we will take potential difference, on y-axis we will take electric current. So you can take according to you, like potential difference we are taking on x-axis, you can take like 2 4 6, 2 4 6 8 10 and then 12, and after that 14, because last number is 13.2. Getting or not? In case of any doubt you can ask like this: 10, 12 and 14. And on y-axis we will take current. So last is 4, so simply you can take 1 2 3 4, 1 2 3 4, plot it. First is 0.5 and at 0.5 1.6. Plot it, students, and let me know is it a straight line or not. Plotting.
Yes, ma'am.
What about Ayukta?
Ma'am, I'm plotting the graph.
After plotting, let me know, are you getting a straight line or not? After doing, let me know, friends.
Mom,
Hmm.
it is a straight line.
And now you have to calculate the resistance of that resistors. How will you calculate resistance of that resistor? Aikta, can you tell me?
Mom, no.
Okay. What about Thania? Thania, did you also get a straight line?
Yes, ma'am.
Okay. So how will you calculate resistance of that resistor?
Ma'am, I don't.
Okay. So what we will do, suppose a straight line you are getting like this. You see according to yourself, I am only helping you. How will you get? A straight line you got? So you pick only 2 points. Actually, what is resistance? Resistance of the slope. Resistance is the slope. Okay. Sorry, slope, it is given by the voltage. एक second, I am getting confused while telling. I will write the line which I am telling. Write the line. You have to write the slope of the line gives the resistance of that resistor, because it is V upon I. V upon I is the resistance. So write down the line, the slope of the line gives the value of resistance. Take 2 point, join it like this, and till here. Okay. So at this point, suppose I am taking this point B, take the value of V as well as I, and also for point A, take the value of V as well as I. And what will be the slope? V2 minus V1 upon I2 minus I1. Are you getting? Take any 2 points of this graph, subtract their potential difference and as well as their current. This will give you resistance of that resistor. Are you getting or not, students? Please confirm.
I got it, ma'am.
What about Aikta?
Yes, ma'am.
Okay, let me know the value. What you got? Value?
Mom,
Hmm.
I got 1.8.
1.8 you got. What about Tanya?
Yes, ma'am.
Just a second.
Okay, Aikta, You have took 2 points. You have taken 2 points.
Yes, ma'am.
Subtract.
Ma'am, we have to take the points that are plotted on the graph or
Yes, yes.
any.
And you take according to your graph. This is the rough graph. This is not from.
Ma'am, I've taken according to my graph, but
Okay, okay,
that's.
okay. Okay, okay. You subtracted two values of potential difference.
Yes, ma'am.
What you got after subtracting?
Ma'am, it is 1.8 and in the denominator it is 1.
Actually, in numerator, it should be 3.4.
Ma'am, just a second.
Okay, you check according to yourself. Otherwise, what you do, you send me a pic so that I can check. Ekta, now you got correct or not?
Ma'am,
Hmm.
now I've got 3.6.
Ha, it is correct. 3.4, 3.3. By different values, you will get different, but 3 point something it is correct. 3.3, 3.4, like that. 3.6. What about Thanya?
Yes, ma'am.
You got correct answer?
Yes, ma'am.
Okay, now start 8th. Thanya, read question number 8.
When a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit.
Hmm.
Find the value of the resistance of the resistor.
So what is the potential difference?
12 volt.
Current
2.5 milliampere.
in,
Should we convert it?
yes. In SI unit it will become, you have to convert milliampere in milliampere to
Uh,
ampere. And how can you convert?
Ma'am, 1 ampere is equal to 1000 milliampere.
Very good. So, and now you have to convert milliampere to ampere. What you will do? You will
Ma'am, divided by 1000.
divide by 1000. Thanya, are you getting this thing or not?
yes, ma'am.
So 2.5 milliampere will become 2.5 into 10 to the power minus 3 ampere. Okay? And V also given. It is V is given. It is
12.
Ma'am, in case this was microampere, then it would become 2.5 into 10 to the power minus 6 ampere.
very good. Absolutely. And V is 12 volt. According to Ohm's law, what is the formula?
R is equal to V by I.
Huh. And apply this formula. Let me know final answer.
Then it'll become 1. We'll have to multiply with 10. 120 by 25 into 10 to the power minus 3,
Correct.
like that.
Like that. Correct. I want to tell something here. You can do like that, Thanya. It is also correct, which you told me. But still, instead of multiplying, what you can do here, we are getting 10 to the power minus 3. When it will go in numerator, it will become 10 to the power 3.
Yes, ma'am.
Okay, and for eliminating the decimal, simply you will write 10 here, or you can multiply by 10, whatever you want. Both are correct means. So what will be the answer? In standard form, you have to tell me answer. Standard form, you remember? In exponents we have done, like in 8th standard. Let me know final answer. Aita, Thania.
Mom,
Hmm.
I've got 48 into 10 to the power 2.
Very good. Very good, Aita. But I told you have to give me answer in standard form. What is the standard form? That you should write decimal after one digit. So it will become, Tanya, can you tell me?
Ma'am, in standard form.
Hmm.
1 second.
Student, you are taking so much time in telling standard form.
Mom, I don't remember.
Okay, okay. So decimal should be after one digit. So 4.8 into 10 to the power 3 ohm. Okay, we are shifting decimal here.
Ma'am, I did not understand.
You did not understand. Okay. All the things you got, only standard form you didn't understand. Correct?
Yes,
So
ma'am.
I will write only that thing actually. You got answer 40 8
48 into 10 to the power 2.
10 to the power 2. In 8th standard exponent topic, we have done that the standard form is like that, means decimal should be after one digit. After that, how many digit we can write? We are completely free, but decimal should be after one digit. Are you getting?
Yes, ma'am.
Okay, so it means I have to put one decimal here after one digit.
Yes, ma'am.
For this, I have to divide it by 10. Means what I have to do, it is 48 into 10 to the power 2. So I have to divide it by 10. Are you getting? It will become 4.8. But in mathematics, it is the rule. If we are dividing by any number, we have to multiply by the same number. So it will become 4.8 into 10 to the power 3. Are you getting? That would be the
Yes, ma'am.
standard form. What about Tanya?
Ma'am, she's not in the class.
She is not in the class?
Yes, ma'am.
Okay. Ayukta, you got it?
Yes, ma'am.
Okay, Ayukta. Now ninth question.
How many how many 176 ohm resistors in parallel are required to carry 5 ampere on
एक
a
second, एक second.
220
Ayukta,
volt lamp?
Ayukta, you skipped ninth.
Acha. A battery of 9 volt is connected in series with resistors of zero point 0.2 ohm, zero point 0.3 ohm, zero point 0.4 ohm, zero point 0.5 ohm, and 12 ohm,
Hmm.
respectively. How much current would flow through the 12 ohm resistor?
Hmm. Can you tell me how will we will solve this one?
Ma'am, V is given.
Hmm. Very good.
Ma'am, resistor is. Ma'am, it is 12
It no. All are connected in.
parallel.
नहीं बेटा.
अच्छा नहीं सीरीज में.
Ma'am, my device switched off. That's why
कोई बात नहीं. We have
I
discussed
joined
only
from a negative.
about the standard form in question number 8. You know about the standard form or not? Tanya, can
Ma'am, I didn't finish it. I was trying to like contact
okay.
you.
Okay. Actually, we got 48 into 10 to the power 2.
Yes, ma'am.
Ayukta, meanwhile you calculate all are connected in series, equivalent resistance. So, Thania, here 48 into 10 to the power 2. What is the standard form? That the decimal should be after one digit. We have done this in mathematics 8th standard exponent chapter. To put the decimal there, it should be divided by 10. If we are dividing by any number, it should be multiplied by the same number. So it will become 4.8 into 10 to the power 3. Getting?
Yes, ma'am.
In 10th question, sorry, ninth question, potential difference 9 volt is given. All the resistors are connected in series. Okay, for 12 ohm, they are asking. In series, current will remain same in all.
Yes, ma'am.
So as they are in series, firstly we will calculate equivalent resistance. In series, how can we calculate equivalent resistance? By
Ma'am, adding up them.
Adding
adding.
the
And
resistances of the resistors.
and what we got?
2.6, I think.
2.6, all point 2, point 3, point 5, point 9, point 5, 1.4, 13.4 it should be. Please check. Add all.
Oh, yes, ma'am, it was 13 point.
13.4. Now calculate.
But, ma'am, we have to find for 12 ohm resistor.
But these all are connected in series and they are asking about the current. Current will be same in all. Current will
So,
not
ma'am,
be
we need to take V as 13.4.
R.
R, sorry.
Yeah, and V is because current will be remain same in all. Let me know final answer.
Ma'am,
Hmm.
I'm not able to divide further.
Okay. You got 9 upon 13.4.
What, ma'am?
9 upon 13.4 you got.
Yes, ma'am.
It will become 0.
Yes, ma'am.
So 9 0. You have to give one more 0. So point there 0. 134 6 are 804. Again 0 and it will go 7 times. 938. And here 134 ones are 134. 671 would be the answer. Okay.
Yes, ma'am.
What about Tanya? Are you okay with it?
Yes, ma'am.
So, friend, that's all for today's class.